My name's Don Robinson. Some of you will know me as a contributing editor to Streaming Media magazine. I've been writing for the magazine for not quite the full 21 years, but for about 18 years, and so on. So these days, increasingly musing about big industry topics and forward-looking things and so on, as my own software company started to produce technology right across the stack. So by day, I do biz dev and sales for a software company, a UK software company called Ideas, and we're very much a pure microservices company. We build all our software in Erlang, which is a particular type of language, great for doing microservices architecture at scale and so on. But I won't go on about that because we've got a far more interesting panel of esteemed representatives from companies you will have heard of that we need to meet and get stuck into the topic of OTT moving towards microservices. When I pitched this session to Eric, who's the VP of the magazine, I thought I'd start a new strand of when I come and host and moderate panels at streaming media conferences, I'd pick up on topics from feature articles that I've written over the previous quarter or previous few months. So one of those two articles was OTT moves towards microservices. So if you haven't seen that, then either grab one of the copies of the recent magazine or find it online or come and ask me after the session. But today, what we've got is 5 great panelists to come and talk about this evolution called microservices and so on. What I'm going to do is ask each panelist just to give me a quick introduction to themselves and to what their company is about and so on. And then I'm going to, just to give you a bit of a heads up, guys, your first question is going to be on coming to some sort of consensus on a definition of what microservices actually is. So that's a bit of a warm-up. But don't go straight into that yet, just a little introduction. Stefan, can you lead us off and give us an introduction?
Sure. My name is Stefan Lederer. I'm CEO and co-founder of Bitmovin. We are a video infrastructure provider, a software provider in the video space. We provide video encoding, player, and analytics. And we are a relatively young company. We started 5 years ago. And when we started, microservices were the new hot thing, how to develop software. And that's basically the foundation of what we do. We build our services with a microservice architecture in mind. And that's also how we structure our teams. I mean, you can learn a lot from companies like AWS, which kind of like created the whole topic to some extent. And we really see, okay, writing a video encoder, writing a video encoding service comes along with so many different pieces. You have the encoder, you have the API layer, you have the scaling layer, you have the rate control, you have the packager. All of that are perfect for microservices. And you have a lot of complexity associated with those pieces of an encoder. And again, here you can split the effort again. A microservice should not have more than like 12 engineers working on it. And that's exactly the nice thing you can apply on such a product. So for us, microservices is basically our DNA, and that's how we build and live our products. And so far, it's running well for us, and that's also a source of competitive advantages for us. Perfect.
Olivier.
Right. Good morning. My name is Olivier Karra. I work for Harmonic in the marketing organization. So I'm specifically looking at the OTT and IPTV market segment. And for those who don't know what Harmonic is doing, we're a technology provider. And our goal is really to enable media companies and service providers to provide the best possible experience for OTT and actually still broadcast delivery. So in terms of microservices, just to give you a bit of background, about 3-4 years ago, we had to transition our portfolio of products and solutions, and that meant a full redesign of the software platform. And we took this opportunity basically to leverage the microservice architecture to make sure that it would basically be the part of the foundation blocks for all the solutions that we would provide, whether they would be used on premises, in a bare metal or private cloud environment, or in a public cloud environment, or in a hybrid mode. So this is really why we are using microservices today.
Perfect. Mark.
Hi, I'm Mark Russell. I'm the CTO for MediaKind. MediaKind is a media technology company. We're in the process of spinning out from Ericsson, who was probably a more familiar name to most all of you here. And we have a product in compression, delivery, cloud DVR, and in building TV experience is what we call a TV platform. Really, and then in terms of customer base, we have a large business with broadcasters and media content companies, as well as pay TV operators itself. So kind of have a foot in both worlds, if you like. We would have maybe a bit of a similar story to my colleague here from Harmonic, in that we had pre-existing business based on certain standards of quality and in a certain sort of deployment model. But clearly, as time has moved on and as sort of the streaming space has become very prevalent, we've put most all of our energy into cloud-native technologies. We think that for flexibility purposes, for the ability to really give kind of a malleable service, it's kind of really the only answer that's going to make sense for players of all dimensions in this space. So that's where we've kind of put our bets. And then I guess finally, as we think of microservices, we quickly sort of skip to Linux containers as sort of kind of the medium on which you package that value. So that's something we'll probably talk about in this panel.
Sure. Xiaomei.
My name's Xiaomei Liu. I came from Netflix. I'm a senior software engineer in the encoding technology and the video algorithm team. I think Netflix is a well-known company. We're providing the global scale internet entertainment. And Netflix is an early adopter of the microservice architecture. And we have contributed widely to the technology community about the best practice and a lot of the open source tools.
Cool. And Steve?
Yeah, thanks, Dom. Hi, everybody. I'm Steve Miller-Jones. I'm the VP of Product Strategy at Limelight Networks. Limelight Networks, we're a global content delivery network. We've been around for quite a while. Our mission is to securely manage and globally distribute digital content. And what I think is interesting about the stories around microservices sort of have many facets to them. But if we look at how we develop new features and functionality now, how we think about the rate of velocity of change, or how we deploy more straightforwardly, and how we manage an increased rate of change in what is a global network, microservices make a lot of sense for us in order to think about how to do that. If we think about the great grouping of things into what people like to call edge services, or the use of a network layer in order to deploy more services, obviously, again, velocity and flexibility and agility are key in being able to compete there. And a lot of the time, we see customers demanding features of us and demanding a velocity in our ability to change for their needs, or enable them to use our service, traditional platform as a service or software as a service, enable them to use it in a different way. So for us, microservices, as I've run product management over the last sort of 3-4 years, has been a key part of how we transform our business. I agree, I think it can help to seed in a business a form of competitive advantage, although of course, real competitive advantage comes from the products and services that you have. The agility and flexibility at an organizational level certainly are absolute benefits of having a microservices-oriented architecture. It gives you a different approach to what were monolithic applications in the past.
Okay, cool. So let's start at the beginning. Now, there's no right or wrong answer to this next question, so don't feel like I'm trying to sort of put you on the spot here. And in fact, I aim to ask this question because I precisely want to bring out the conversation about the nuances in interpretation of what the term means. But let's just hear a little bit from each of you about what microservices architecture, what microservices means to you each as companies and as individuals. Stefan, kick us off. What do you think of as microservices when you think microservices?
There are different angles to that question. I mean, for us, it's about reduction of complexity. That you take, okay, you have a monolithic software, and you take different functional blocks and whip them out and build that in smaller, specialized teams and provide interfaces to that specific functionality. A great example came from AWS, for example, or from actual Amazon in general. So they split out, for example, the login service. They split out the item service and so on and so forth. So every piece of The Amazon product basically is split out. The same thing we do, for example, for our encoder. And with that, you can really specialize teams, and you can also provide much more reliability here. You can also split out the different databases and focus them on the scalability for the actual functionality. You don't create artificial bottlenecks into engineering resources because you have much smaller and much more agile teams. And you have to be careful. As soon as you start to take your monolithic software and split it up, all the different pieces are also growing again as your business is growing. So you have to continue that approach and go down further down with the components that you are splitting up. So for example, when we grow a product, when we grow a team, every year we increase the amount of different microservices so that people can focus on them and can make them reliable, scalable, and perform it for its own, and make sure that the overall product in the end works together. So that's pretty much our approach to microservices. And yeah, that works.
Okay, cool. And Olivier, please.
Yeah, I think we're pretty much aligned because, in the early days, we would typically have this big monolithic application, which would really have a pretty wide range of workflow support. And when we moved to this microservices architecture, the whole point for us was to split this into individual blocks. And really here, the challenge, or one of the challenges, is to figure out how low you should go in terms of splitting up those media functions. And this is not obvious from day one. So the two things that we found out throughout the cycle is that because we're dealing with video, and that can lead to a pretty significant amount of data to process, you cannot go that low in terms of splitting up those media functions. And then the other point is that at the end of the day, we're dealing with real-time services. So the processes need to be kept in sync to some extent. And that also will basically frame what you can or you cannot do with microservices. But typically, I'm going to give you an example. In the old days, we would have, for instance, processed or implemented a live TV transcoding service into a single code, whether it was doing, real-time encoding, SCT stream table extraction, or signaling extraction. Today, those would really have separate microservices. And if you think about it, they have nothing to do with each other. They are very specialized functions. Yes, they are part of the same service because this is a logical link. But in the end, really, they are completely different tasks that need to, and this is why we would basically split them into microservices. That's our perspective, really.
Okay, Mark?
So we have two very broad chunks to our portfolio, and each of them sort of drive a different perspective on how you architect a system. And there's some commonality in building things out of microservice-based components, but we've learned different lessons from different parts. So the first part, I think Olivier has covered very well. We have a media pipe that's built in compression and delivery components, and you use microservices in that layer very much in the way that you both have suggested. In our platform part, these are things where you're building subscriber management systems, you're building things that interact with users directly, you're building in the underlying analytics that understands why they're there, what they were doing, what they like to do, why would they ever want to come back. It's the things that an operator would use to build, or a broadcaster would use to build a service on. There, we kind of come from a little bit of a different angle. I built a product when I was at Microsoft called MediaRoom, which is an IPTV platform. Had quite some scale, quite some success to it. It was a web service-based architecture, a bit of a precursor to microservices. So we got a lot of good experience on factoring APIs and factoring, components. But it was still sort of deployed in kind of the same old way you would deploy mission-critical products at any type of operator, or these are all operators. And I guess the thing that really struck us was it was very hard to change, very hard to deploy, very hard to put new features out for subscribers. And now you've got folks who are competing in the same space as Netflix or Facebook or others who, really have quite a dynamic service, one that goes everywhere, one that kind of, there's not one Netflix, there's millions of them. It's very tailored to you. And if pay TV is going to have a future, it has to have that future. So we've really sort of designed to that design point, and we think that microservices and the container architecture that goes along with it is sort of key to making that happen.
Okay, Xiaomei.
For us, the microservice, we break this complicated service to smaller pieces. So each one of the microservice has a well-defined, a service contract. But what is very important aspect I want to say here is the microservice not only enable us to have this separation of concern, both at the technical side and also at the organization side. Where I mean at the organization side is really each microservice considered is managed by independent team in the organization that manage the entire life cycle of this microservice. So from the architecture, from the design, to the development, to the testing, to the deploy, to the run, to the support, the entire life cycle is independent. There is no coordinated release anymore. Every microservice is a service by itself. That, I think, is my side of view.
Steve, anything to add?
Yeah, absolutely. I think that's really interesting because if we look at what we've done to develop our services over time and then add new services, it poses different challenges, right? So I think we've been orientated around what we might call a service-oriented architecture or component-based architecture for a while. Certainly as we've tried to solve, say, some of the bigger problems in the CDN world of efficiency or improving throughput or improve metrics like quality of experience metrics like rebuffer rate, and we focus in on small things, we've broken out components so they're more easily manageable and there are specialist teams and we can iterate on them and deploy in a more individualized way rather than have to do big coordinated change activities, which, let's face it, are both high risk and take a lot of resource and time and effort and are really difficult sometimes. So it's been really interesting to then look at brand new services. So, the real-time streaming service that we just launched is based upon a series of middleware options which we've had to use existing services and develop from, and brand new things that we deploy into the network. So this idea of small specialized teams who are able then to focus on individual particulars of a service-oriented architecture and be in control, as the Americans would say, soup to nuts or end-to-end of that piece, and maybe get out of the business of, well, I've done my development and I've done all my unit tests and here's my handed off code and now here's my DevOps and here's my change piece, right? Get out of that business into the CI/CD part of microservices, right? I think makes it really flexible. So that's been really interesting in a product like real-time streaming, which obviously has a series of stacks involved. And then we're looking at some new services around things like function as a service, which really, the point there is to be very generic, right? You use reusable stacks that are readily available, easily supportable, and build brand new services on top of those in small specialist teams. So I think if you look at new things, it's much easier to get towards what we're calling a service-oriented architecture and microservices. If we're trying to iterate on and continue to develop old platforms, the technical debt to bite off and wholesale lift and replace an end-to-end service with microservices and very small teams is considerable and will take a lot of time. And you have to balance that with the day-to-day BAU risk of just continuing as you were and taking a part and going, you know what, it's time to break this into components and then making that investment. So it's a real interesting, for us, it's a case of continuous development continuous transformation and innovation in our development path to get towards more microservices. And as we add new things, which are that orientated, it's a really interesting learning curve culturally for the business. So everyone learns from each other. That there's a whole sort of educational aspect to it, which is really beneficial for the culture and diversity of the teams as well. So I think there's a lot of really good things in it, organizationally as well as technically.
So, as some of you will know, I'm a bit of a pedant when it comes to terms, especially marketing buzzwords and so on that get introduced. And my next question is really a bit of a dig at the misappropriation of the term microservices architecture. So we'll keep this one brief, but I think it'll present an interesting counterpoint. But just quickly, from each of you, what is not a microservices architecture? I might just start the ball rolling for 10 that I don't consider putting a monolith in a Docker container a microservices architecture, just to steal that win from all of your thunder. But if we could just go along the table, if there's some things that you would specifically define as differentiating things that are not microservices architecture from things that are. Stefan.
I mean, the monolithic approach, as you say, putting that in a Docker container or in a VMware is obvious, the most common mistake that marketing does when it comes to microservice architectures. But it goes way beyond that. I mean, you mentioned continuous deployment, for example. Those things are the really interesting thing. A microservice architecture-based system doesn't come on a USB stick. I mean, that's something that's alive. I mean, that's updated multiple times a day, multiple times a week. You don't have like one software version at once, and then you update the whole thing, you take down your server, you boot it again, and then you have another software version running. That's not how microservices are working. You have a living system where you have different versions of a microservice, you upgrade the version, you run a part of your traffic in a canary deployment, you test it out, you see if it scales, you shift your complete production traffic to this new version of the microservice and then run it up. I mean, that are characteristics of a microservice versus like putting one monolith into a Docker container or a VMware.
Olivier, anything to add to what's not a microservice?
So in fact, maybe what I can add to that is for us, there is very much a notion of clustering and orchestration, which often comes with microservices. So it's true that you could think about a software platform without those components, but in general, they would complement very, very well. And then the second important thing that I think should be seen as a must-have together with microservices is first the API, so that it can be really used in a proper way with public API calls that are readily available. And then the second point is really the need to have its set of test sequences, because really without that, there is no way you can verify the microservice really does what it's supposed to do. So I think if you start removing those kind of add-on capabilities or components, then I think there is a much lower value into the microservice itself.
Mm-hmm. Mark?
So I would agree with what Stefan and Olivier have outlined here. Microservices live in a ecosystem, if you like, and if you don't have the whole ecosystem, the microservices itself is like microservice is just a unit of packaging of, some defined service. If that's not built as a 12-factor app where you've really paid attention to your APIs, you have automation in terms of how the product is built and how it's tested, and indeed how it's deployed. If you don't have that notion of continuous deployment and evolution built into the concept of your product, then microservices is sort of an uninteresting thing to deal with. Once you get there, then you find out very quickly how you're going to get yourself messed up if you just take a monolith and stick it in a container and try to float it. You can't deal with a monolith in the way that in a continuous evolution fashion. You'll quickly come to grief with that, and you'll find you'll have to start to split it up. Now we live with a foot in both worlds. Sometimes I think we have 1.5 feet in one and a half a foot in another. Our broadcast and operator customers have a lot of legacy. And we respect that legacy, and so we're trying to bridge that world between a legacy that we're an honored part of, and then trying to bring them to evolve into sort of a new space, which is very hard to do. And so you get a lot of bending of the rules, if you like, when you're doing that, but you're doing that in the service of trying to do something good in the end of the day. So.
Xiaomei, any thoughts on what is not a microservice?
Yeah, so in my mind, what is not a microservice is, I don't know if people have heard of the term distributed monolithic. It is distributed, but it's still monolithic. Why do I say that is because microservice is really, we emphasize this independent of each microservice. So if you have a distributed monolithic, when you do this release, coordinated release, that's not microservice. That's still a distributed monolithic. Then people are thinking about why there are this distributed monolithic. What makes it not microservice is this tight coupling of each of this individual component. And where this tight coupling come from is on one side, it can come from common data model. If each of these microservices share common data model, there's where one of the tight coupling come from. On the other side, if a lot of these microservices, they start to share application level libraries, and then that's also another source of this tight coupling where it come from. So then basically then give you a distributed monolithic instead of a microservice.
Okay, Steve, any last thoughts?
Yeah, I mean, a lot of what I've taken notes on has been said, which is always good. But I think it's really easy to assume that if you decide to build a new set of APIs to front an old monolith, that's microservices, and it's not, I think, to your point. So that's a key thing, and I think that's where, Dom, you dislike the collision of marketing and engineering terms, but I think that's a really, really common one. Hey, we built a whole new API stack that fronts all of our software and services, but there's the monoliths, but I have a microservices layer. So, I understand both sides of that, but that's certainly not microservices technically. And I think the thing that both Olivier and Mark spoke to, a microservice having its own automation in terms of testing and deployment is critical, right? If we have to go through an elongated change process to deploy a microservice that's not a microservice in reality. So there is this cultural change to thinking around the risk of change and managing change and putting things into a change window and all those processes, which make sense for monoliths and for distributed architectures and services which have equipment in many places. But I think if you're to truly orientate yourselves at microservices, it is about thinking that the group that's managing the software is in charge of the automation of testing and deployment as much as they're in charge of the architecture of the microservices and how the application overall is built and run. So I think those are two things that I strongly agreed with.
Okay, I've got an easier question, I think, coming up now, guys, because I think what's not a microservice is a reasonably challenging question in its own way. So a little bit more of a broad question here. What are some of the common technology stacks and approaches that you're individually deploying? You can get technical here. I'm not afraid of that. I don't know about the audience, but let's scare them if they are. So talk about some of the technologies that you're using in deploying your microservices strategy, Stefan.
Yeah, I mean, it's kind of like combined microservices. When you talk about microservices, you talk about Docker and Kubernetes and things like that. Obviously, we are using those infrastructure layers, but they are not necessary to build a microservice architecture. Actually, sometimes you don't even want to go in that route. You can go, but I mean, it really depends. In our hosted services, for example, we use Docker, but we use Kubernetes for some services, but some not. In our deployed services on-prem, for example, we use Kubernetes as an easy infrastructure layer, as an orchestration layer, but it's not necessarily bound to it. So I wouldn't necessarily say that Kubernetes or Docker I must have from a software stack perspective for a microservice infrastructure. It typically helps you, but sometimes it also comes with a little bit of management overhead, where exactly microservices should help you to reduce the management overhead and make services independent from each other versus like orchestrating the Docker level, for example. So I don't think there is a specific technology stack that's required or directly bound to microservices. I think there are much more like architectural patterns, like service contracts, API definitions, and things like that. It's more like software architecture and software design versus the actual tool set that you use to implement it.
Mm-hmm. Olivier, any thoughts? Any
So in
comments?
fact, there are a lot of tools and techniques which are coming straight from the IT industry, which we are leveraging. And really, over time, they prove to be extremely powerful and useful. For instance, to coordinate all the work between our development and QA and early deployment, for instance, we use tools such as GitHub for repositories and versioning control, or that kind of things. For continuous integration in development, we use Jenkins, for instance, and that helps us really test any functionality, whether it's in alpha stage or not, without having to pause or delay the workflow of code development. And then, as I mentioned before, we initially started for historical reasons with Mesos cluster management and Marathon for orchestration. But we are moving also towards what we see is becoming a trend with Kubernetes orchestration or scheduling of microservices. And yeah, there are a number of other tools that are really all together making the whole platform extremely powerful. Whether it's a matter of being agile, I think that really proves to be delivering what we were looking for. So that's just a few examples of what we use.
Perfect. Mark.
So, I'd probably second the continuous development stack. Really, when you're thinking about microservices as a subject in itself, that's software development. So you're going to think about whatever your favorite editor is. We won't get into that. You can use whatever you want. But at some point, you have to push a button, and you have to compile it and build it and test it, and you want to make sure that that's automated. So Git. Jenkins, there's a number of other components that are really out in the world. They're part, and I think this is an important aspect of it. It's important to step back and separate the value that you're adding with your whatever your services or the software that you're building, and then really be objective about the value that's kind of been added by the world and is yours just to adopt. So things like that are very easy to pick up and use, and it has a double benefit that it helps sort of industrialize this notion, because there's a big community of developers who are familiar with those tools. If you are in the vendor space, your customers will become increasingly familiar with them, or they're teachable in a good way. I think from our perspective, I'd have to also highlight that we've put a lot of energy into Kubernetes in terms of orchestrating containers across our portfolio and really helping us think through our architecture and sort of the supporting things that you need in a microservices architecture. Things like discovery, things like being able by a recipe to auto-scale, to spin things up, to tear them down, to just give them business rules for that. Those things are difficult to get right. You want to have a platform that has some mass and some scale to it to do it. Now, what we do is at least at this point, everything that's required with our product we ship with. So we don't have a dependency on anybody's particular platform to take those things unless somebody wants it. But we have felt like it was important to make real intellectual investment in the nuances of Kubernetes and really sort of understand how to architect around it. And so we've put a lot of energy there.
Xiaomei.
In terms of the technologies used to build the microservice, these technologies can be in multidimensional, and each dimension there are multiple choices. There is no magic like a technical stack. Just pick the best one for your situation. When I try to see all these dimensions, for example, there are the data center choice, and you can have like AWS or some Windows, Azure, or even your own data center. There is the virtual. There's this dimension of this virtualization choice. You could have VM-based or container-based. There's two choices. And if you choose the container-based, then there is this orchestration layer. There's the popular technology choice are like, for example, the Apache missiles, the Kubernetes, or maybe even your own. I think like Mark mentioned, they invested a lot in the Kubernetes. And for Netflix, we based our like orchestration on the Apache missiles. So basically, there are a lot of different choice. And another separate dimension is about all this communication layer between microservices is very important because all these microservices has to efficiently communicate to each other. Two typical choices are like REST-based, REST HTTP-based communication or RPC-based communication. That's other choice. And of course, there is some other like dimension, like how you have the persistent layer with like SQL, non-SQL, or some other mechanism in the area of queuing, all these things. So each dimension, there are multiple choices.
Mm-hmm. Steve.
Yeah, I like the multi-dimensional approach. I think you guys have touched on a lot of, rather than me just repeating those things, I think I'm going to approach the question from a slightly different angle. We built a new service called Smart Purge a couple of years ago, right? It was to solve a specific problem of, how do you, if you need to, very quickly get rid of something that's in a cache? Okay, that common problem if you have a video chunk that you've misencoded, or it has the wrong bug in it, or takedown request, or whatever. And this was a real challenge. So we took a real design-led approach, and I think this is critical in not only microservices, but any software development, and microservices in particular. If you're going to break things down so that individual services are self-contained and have like a meaningful output for support, so you can quickly triage and bug fix and iterate and release fixes, for example. So we had a real design-led focus on the requirements of how quickly it should take to do anything. And this kind of took us to a point where we had like 5 key parts of the system we had to develop. So we had to create a mechanism to create some form of query language that people would be able to use through a common API to describe what they wanted to purge, get rid of. That, in itself, the mechanism of describing and writing that to a database, for want of a better word, that was a key microservice in itself. Second one, batching those, putting them together into groups that could be distributed and acted upon, executed, or batching, or knowing then actually we shouldn't batch them and we should be able to apply different levels of quality of service to different customer types. Thinking about batching was then another different microservice that we needed to use in order to put these queries together. We then looked at distribution and state tracking. Right? Did we distribute something? And can we track the state that request is in when it's gone out? So we wrote a whole load of our own protocols for managing the distribution of these queries and these batches and determining if they got out to the edge so that we could be sure we were hitting the requirement of being 99.5% sure, or whatever the number was, that we're going to actually get rid of that object that's in cache. Because the worst thing when you're purging is, I told you I purged it, but your next request still got the old object. So those 3 things, distribution, state tracking, and the messaging protocols, we consider to be independent services too. So to sort of approach all of those and then give that to an operational team who are going to get speeds and feeds from the system. How many requests are we doing? How quickly are they being executed? Are we breaching our SLAs on purging? And be able to escalate quickly to someone who can implement and change the system was really important. So the other part of the microservice, the self-containment of it, is being able to get core data out quickly. So whether you use Zabbix or whatever your monitoring systems are, that's a really cool part of microservice design, I think. So long-winded, but I try to approach it from a slightly different angle rather than technologies, but how did we approach a problem?
Okay, so I'm going to combine a couple more of the technical questions into one overall question, so feel free to pick out the bits that sort of jump out at you for answers and so on. And then after that, I'm going to come and see if there's any questions from you guys so that we can make sure that you guys get the opportunity to ask sort of more business or more technically focused questions from these guys. But let me just spin this one along the queue for the moment. So 2 questions together really. What are the key technical benefits of a microservices strategy? So just purely technical in that look. And then also, what are the key technical challenges in a microservices strategy? And maybe that's a business challenge in adopting them, or maybe that's a technical challenge at an infrastructure layer and so on. So, Stefan.
I mean, it comes with a lot of like benefits. If you take a monolithic software, like take a video encoder. I mean, we are a video encoding vendor, and we took benefits out of microservices for the video encoding process. So a typical video encoder runs on one box. It's one monolithic software. A certain box, a server, has a certain amount of CPUs, GPUs, capacity. Now, you look in the media space, you see increasing resolutions, increasing bit rates, new codecs coming on top of that with higher complexities involved. So actually, the hardware that that's underlying is not growing as fast in terms of performance as the computational need that you have. So we saw that, and we said, okay, that's not the way how to develop a video encoder. So what we took is a microservice architecture for a video encoder. We said, okay, let's take a video asset, a live stream as well as an on-demand asset, and then split it up in different processes, different worker instances basically, which are using different microservices for pre-processing, for encoding, for post-processing, packaging, manifest generation, and so on and so forth. So when we get a live stream or an on-demand file, we spin up dozens, hundreds of instances, depending on the complexity, and distribute that across this fleet of different microservices that we are operating, microservices of the same type, like for example, encoding microservices, and also different types of microservices like packaging, like manifest generation, and so on and so forth. And that gives us now the opportunity to deploy much more complex codecs. For example, AV1 got a lot of attention this year and last year, and the main point of criticism was that it's so complex. It takes forever to encode a single frame, not even speaking about the whole asset. But if you just distribute the whole workload for an asset, then you can actually be very, very, very efficient. I mean, with our microservice architecture, we can encode an AV1 asset in faster than real time. And that's only because of the software architecture that we are building. Of course, we're optimizing the encoder itself and so on, but that's one of the multiple microservices that we are using. And that's a great example to see, okay, what's possible by just changing the architecture of how you implement software.
Excellent. Olivier.
Right, so on the challenges side, maybe I can give two angles or perspectives. I mean, for us as a technology provider, for instance, there is a very good fit with the agile development methodology. Smaller teams which do not need to be centralized. In fact, most of the groups that we have working on those microservices are completely distributed globally. So, I mean, if we look at the alignment between how the application or the code is being written and how the human resources are working, this is a very good fit. And for us, it's a straight benefit that we're leveraging every day. Now, for the end user perspective, one use case that is working extremely well is, for instance, the capability to do upgrades without interrupting the online streaming services. Especially if you're running in a cloud environment, you can just spin off parallel microservices that will work in parallel. And when you're happy that this newer version or whatever this new deployment is working as expected, you just flip over. And this is really a significant benefit from at least an operational standpoint. Now, you had a second question. I think it was around some of the challenges. I mean, if I can share one example that was not obvious to us initially, but we figured out over time, is really to deal with big data. So now that we have split this big monolithic application into tens or hundreds of microservices, you end up with a scary amount of data that you have to store, archive, parse, analyze, and I think it's just the very beginning. I think, Mark, you touched base on this in the presentation this morning, because at the same time, the way we look at it is a gold mine. Because when you see all these content providers and service providers who are starving for quality of experience metrics and feedback, this is where we can extract a lot of the information. Maybe not everything, but as we learn over time what metrics to leverage, then I think we can build some very interesting trends and analytics that will make sense. So just an example.
Excellent. Mark.
So I think for us, I'd point out challenges in a couple of different areas. The first area, I think Stefan and Olivier alluded to, you really just have to think about how you architect differently in this world than you did before when you were basically architecting a pizza box, or you were basically building something that was bespoke for a specific purpose. At the compression, more the media processing layer, you need to think a lot about parallelism. You need to think a lot about how you affect that in your architecture. And then as you think about having that live out in the world where there's some expectation of quality and robustness, well, how do you back that up such that if you lose a core, you lose something, you've got something that can step in its place, and you don't have a profound effect on the user experience. So different way of thinking about quality. We have another layer of our portfolio that is more about the user experience, which has its own kind of very different challenges. We learned a lot from Netflix in terms of how to deal with those, where you really want to make sure that you understand what parts of your application are going to scale with the number of users of your system, and you have those components, clearly auto-scalable. You're just not going to get the benefit out of cloud scaling if you don't do that. It's trickier to do than it may appear on the surface. The other part of that equation is making sure that all of your components in your hierarchy are stateless, and that state is spread across availability zones. It's one of your main defenses to the instability of the cloud. You have a problem somewhere, you spin another instance up somewhere else, all of the state is there, your users may perceive some momentary thing or some graceful degradation of the service, but otherwise they're fine. This is hard to do. And then I would say a third one, we're not a service provider, we're a vendor. And so helping our customers who are used to very linear thinking in this area, come to terms with that reality has been a real challenge. It's one I think we're making progress on as an industry. I'm sure everybody in this room has got some experience with that, but it's one where I think we've got a ways to go before we're all the way there.
Xiaomei, any thoughts?
Yeah. From our side, our organization, the key motivation to go to the microservice is really about the developer productivity and the service velocity. And when the encoding technology started several years ago, it's a small team with engineers knows the entire system pretty well. And as the time goes on, the development team got doubled and tripled in size. And the use case we are covering expanded significantly, both in the breadth and in depth. It's very hard to find engineers now fully understand the system, and it's become increasingly difficult to add features. And when in production, when the issue come up, it's a really expensive chore to fix production issue. And it has been placing the heavy taxes on all our developers. And so basically what those common data model and this monolithic approach that works well for us before and now becomes a liability. And that makes the major motivation for us to move to the microservice. But on the other side, if you think about the microservice has that many advantages. It also doesn't come for free. There are also challenges when you move to microservice. For example, when you have the microservice to construct this a single service, consider the request of a single service request now has to traverse so many microservices. And you have to really make your service monitoring, service logging, all this tracing, debugging across all this microservice to work in order to support this service. And also think about there are so many different microservices construct your entire service. Each one has its own release cycle, all this moving along by itself. How do you make sure all these versions are all compatible without all this, major coordination among all these microservices? There are also other challenges, like when you have many microservices to construct your service, and in terms of service SLA, what does it translate to the SLA or implication to each of the individual microservice, right? Also, the other thing is, when you think about the microservice, it's still a service. There are a lot of aspects that are common among all these microservices. When you have all different kinds of the microservice team, it can be over 100 microservice team. You don't want each individual team to reinvent the wheel about these common things that needed by the microservice. So in Netflix, we have this, we invested in this centralized engineering for all this tooling that's needed by all the microservice. For example, this container orchestration is one tooling, and all these continuous integration, continuous deployment, all these tooling, and some of the tooling related with the developer productivity, how to do the Docker local testing them locally, all these things, and some of the common things like the RPC among the microservices. Those are all common things. A lot of these common things, you really need to put some investment, make sure those are readily available for all your microservice teams.
Steve,
Yeah,
your brief thoughts. We've got I want to leave questions.
sure. I think those that you just mentioned are common themes across teams where you're all trying to work. Like, as a service provider, we're trying to produce a final product for our customers to use and deliver content to consumers. And this sort of reinvent the wheel constantly on each service is definitely a challenge. I think a lot of this comes back, I'll take a slightly different angle. I think there's a lot of cultural pieces in here in a development organization, an operational organization, in a service-orientated delivery business. Our approach to change and the risks that we take, or the risk profile we like to maintain in order to update services in 80 locations around the world so they don't impact people when they are caching services that have persistent data, or data that certainly should persist for a period of time, or that do maintain state and need to. Some of the microservices are very hard to then break out, but as you move to gain the benefits of end-to-end horizontal scale, or gain the benefits of improved processes to flip from one version to the other, right? I think the approach to change has to, and the culture in the business has to orientate itself. You're basically saying, here's a development group who are going to do all of their own automated testing and deployment, and then you operational group are going to run it, and you're going to understand the messages that come out of it and be able to triage quickly. That's a huge cultural change in some cases from a development group who are going to then work hand in hand or hand in pocket with an operational group to understand service reliability and work as a real team versus I develop the software, I automate and test it, I deploy it, you look at the speeds and feeds. So the cultural piece is really interesting, and getting people orientated that way. And then walking backwards, another cultural piece, I mentioned earlier, I think the design approach to applications is really important. Just because you can use microservices, maybe you should, but actually, have you designed it well? Is it fit for use? Are you going to give a product to the end user of that who's going to benefit from that at all? How have you thought about your requirements for scalability, for capacity, for latency, for common services that you're going to need to build? If you have an SLA of you have to deliver in 5 milliseconds or you're in breach. Right? If you have 15,000 microservices working together, each with their own implementation of an RPC, for example, are you even going to be able to get there, and can you track it? So there's a whole cultural piece stemming from design and requirements definition right through to then the deployment and operational side, which I think is really interesting and challenging for any industry. But I think that has a real impact as well.
Perfect, thanks, Steve. Okay, how many questions have we got coming in from the floor? I just want to time these. So I'm going to basically pick up, we've got 3 or 4 questions, so we'll just pick 1 or 2 of the panel to point the questions at. Start from the front, please.
Thank you. Dr. from Matrix. Fascinating discussion. Thank you guys. It's nice to be a purist, but very few of us have the luxury to start from scratch and build an ideal service-oriented architecture. I think Mark may be in the same boat that we are, with a lot of legacy, but you still want to move to this new architecture. How do you approach the problem of not deleting everything you've built in the last 20 years, but still finding a way to migrate to where you want to be, using some of the legacy code and legacy services? Any guidance there?
I'll take a
Go for it, Mark. Yeah, just sorry, let's keep it
I'll
brief
take a
so
crack
that
at
we
it
get 3
since you
questions
said
in.
my name.
Yeah, let's go for it.
So I think what we found, now this is germane for those of us who are vendors and we're working with, we're not the service providers, so we're providing technology to folks who are providing an end service, and we're trying quite candidly to influence that community to move in a certain direction. What we've looked for were disjunctures in the service. So for example, if we think about the whole subject of direct-to-consumer products on the broadcast side, or streaming TV in the IP or in the pay TV service provider space, that's kind of a perfect place to say, hey, let's take a bit of a different approach and put not only a new infrastructure in, but one that's operated differently, one that has different characteristics, and one where your consumers might have some different expectations of. Very hard conversation to have, but we found that one kind of works, and then you have the gummy problem of, okay, what do you do about the services that may or may not be left behind? And that's, I don't want to go on with that. That's a long answer.
I'm going to at least get the other 2 questions in off the floor, even if we run out of time. Second.
Yeah, thank you. This is Stefan from MediaKind. We talked about, thank you for the great presentation, by the way, and we talked about this ecosystem issue, right? The microsystems, microservices. So my question to Netflix, if it's not confidential, is there a case for you that there are operators around and saying that, because I know that you have your own equipment, hardware, built with the software, so are there operators who are telling, this is my microservice platform, can you run it here without you shipping any hardware, just as a service? Can you deploy this way, or is there a case for it?
I think, as you know, Netflix, we build all our service in AWS. So what our philosophy is, we only build what we have to. We leverage the readily available technology, including the open source and all these. But I think as far as I know on our side, we build the service and the entire thing by leveraging the component of technologies. I've not seen this taking the entire end-to-end solution.
Cool, and there was one last question. We're going to go slightly over. There was one last question from the back corner somewhere. Yeah, the hand's gone up. There we go. Have to shout. I think I missed the very first bit of the question. Is there
data sharing between
common practice?
a model for data sharing between microservices?
So as long as you're programming to the API layer, the rule is each microservice instantiates its own data into the data lake, and you can only access it through its interfaces. Now, if you intend for another microservice to actually consume that data, as long as it's using its interface to consume the data out of the data lake, then you're in good shape. You don't want any direct database connections. So you can share as long as you're sharing at the API layer.
So we, for example, transfer segments between microservices, and we do that within cloud infrastructures or data centers. Within cloud infrastructure, this comes with little costs. From a financial side, there are no costs for the transfer. From a data transfer perspective, like the pure time from one instance to another one, from one microservice to another one, it's also not necessarily bad. We see like 10 gigabit and more connections in data center environments as well as in the cloud. So that one works really nicely. And the most important thing is that you have clear API specifications, what the different, like how to interact with each other in terms of like microservices. That's the media payload perspective, but then you have a lot of like additional metadata on top of it. I mean, if you look into an encoder, you have like SCSI triggers, you have like the container format, you have that weight control. I mean, with a distributed encoder, we have a weight control service for that. And those are separate microservices that own the data piece they're responsible for and provide those interfaces. The most important thing is that those services are made for the specifications they serve. For example, if you have a weight control service, that thing needs to answer quite fast because the encoding process needs the data, while other services have other dependencies and characteristics. So I think it's all about like specifying the data flow early on and making sure that the microservice specification is working and then starting building it. So if you do it on the go, then typically there's a recipe for failure.
Just a quick question for all of you guys. Can I just stick your hand in the air if you're already deployed microservices or you're deploying microservices? Okay, that's cool. And is anyone out there definitely never going to deploy microservices architecture? Okay, cool. That's good. We won. Guys, I'd like to thank the panel. A brilliant panel. I'd also